Hello everyone, my name is Prasanna Bengal. My PRN is 202201030003. I'm going to present the introduction to bridge engineering. So basically, bridges are essential structures in civil engineering that connect places separated by obstacles such as rivers, valleys, or roads. This presentation covers key topics including the clarification and classification and the types of bridges, their components and importance, important concepts like economical span, afflux, and high flood level HFL. We will also explore loads acting on bridges, IRC load specifications, and discuss notable failures of bridges in India. Understanding these fundamentals is vital for civil engineering students and professionals seeking to design safe and efficient bridges. So now we will see for the slide. Uh, Classification and types of bridges. It's divided into two types: classification by structure and classification by function. In classification by structure, there is beam bridges. There are beam bridges, arc bridges, bridges, and fourth one is suspension bridges. So first one is beam bridges, simple and short span. Second one is arc bridges that transfer load through arcs. Third one is truss bridges, uses triangular units for strength. And fourth and final one is suspension bridges, uses cables to carry the load. In classification by function, the types are railway bridges, road bridges, pedestrian bridges, movable bridges like swing or bascule types. On the slide, we will see components of bridges. Here, four components are listed: deck, piers, and abutments, bearings, and foundation. First, we will see deck, the surface on which vehicles and pedestrians travel. It transfers load and supporting structure. Second one is piers and abutments. Support the ends, abutments, and intermediate spans, piers transferring loads on the ground. Third one is bearings. Allow controlled movement and relieve stress between the deck and piers abutments. Fourth and final one is foundations. Transmit the load safely to the subsoil. Must use the using properties carefully. On the further slide, the economical span and hydrological concepts. Economical span. The span length which minimizes total construction cost, including materials and foundation work. The right span reduces costs and improve durability of the bridges. And in hydrological terms, afflux, rise in water level upstream due to obstruction. HFL, high flood level, maximum expected flood elevation. And third and last one is core depth, depth of a soil erosion around foundations caused by the flowing water. That's all. In the next slide, it's loads and bridges. So there is a dead load, live load, and environmental loads. First, we will see dead load. Weight of the permanent components of the bridge, such as deck, piers, and grinders, are these all are included in dead load. In live load, variable loads like vehicles, pedestrians, and machinery moving on the bridges. Whichever machines and vehicles move on the bridges are included in the live load. Environmental loads: wind load, earthquake force, thermal effects, and water currents acting on a structure. So basically, in environmental loads, the natural occurrence phenomena are included in this type. Uh, on the further slide, IRC load specification for bridges. Indian Road Congress IRC codes provide guidelines for design load, including vehicular load patterns specific to Indian traffic conditions. Standard load models: Class AA and Class A for trucks, pedestrian load, impact factors to account for shock from moving vehicles. Third and last one is load combinations. IRC specifies combination of dead, live, and environmental load ensures safety under multiple scenarios. Next one is bridge failures in India. What lessons we should learn and we have learned from the bridge failures from India. So there are three lessons learned from the bridge failure in India. First one is causes of failure. Second one is notable failures, and third one is key takeaway. So causes of failures: poor foundation and score management. Second one is overloading beyond de design capacity, and third one is inadequate maintenance and inspections. Second, notable failures. Machachu Dam failure 1979 due to heavy rainfall and structural issues. And second one is Rajpath Bridge collapse 2017 from structural deficiency. So the key takeaways from bridge failures in India are rigorous design, proper hydrological analysis, and regular monitoring are essential to prevent failures. In the further slide, we will see design considerations for safe bridges. First one is safety, second one is economy, third one is sustainability, and fourth one is functionality. So first one, safety. Ensure structure can withstand all the anticipated loads without failure. Economy. Cost-effective design, balancing material, labor, and maintenance cost. Third one is sustainability. Minimize environmental impact during construction and operation. And fourth and final one is functionality. Meet traffic needs and durability for intended lifespan. Next slide. Modern advances in bridge engineering. Basically divided into three types: materials, design tools, and construction techniques. First, materials. Use of high strength concrete, steel, and composites improves durability and load capacity. Design tools. Computer aided designs and finite elements analyze provide precise structural simulations. Third one and last one is construction techniques. Precast segments, incremental launching, and advanced scaffolding speeds up safe construction. So now we will see the overall conclusion from the slide. Towards resilient and efficient bridges. Bridges play a crucial role in India's infrastructure and economic growth. Mastery of their classification, components, hydrological considerations, and loading is fundamental for safety design. Learning from the past failures and embracing modern technology enhances sustainability and resilience. Civil engineers must apply these concepts diligently to build bridges that last and serve society effectively. That's all. Thank you, everyone.